Hello students, welcome to the 2-week certification course on PLC, HMI and SCADA programming for the students of EC department, BGS Polytechnic, Chikballapur. This certification course is organized by iRobot Automation Private Limited company, and this company's provides training on following technologies, both industrial as well as educational sector. So coming to the video, this video is on how to develop the PLC ladder logic and HMI screen for the given assignment problem, that is controlling of conveyor motors and the motor which are connected to conveyors. There is a sequence given here in the assignment, so we are going to develop the PLC program as well as HMI screen for this. So let us understand first quickly the problem statement. So there is a start switch and stop switch, and by operating start button, and before that there are two motors are there. There are two conveyor belts are there. Each conveyor belt is having one motor. So there are two conveyor belts and two motors are there. Okay. So when we table the inputs and outputs, there are two inputs, PLC inputs, that is start and stop, and two outputs, that is motor 1 and motor 2. It is listed here, and I've taken the address of x0 for start, x1 for stop, and y0 for motor 1 and y1 for motor 2. Okay. This is my address declaration, and I hope you understood. The problem definition is, by operating start button, first motor 1 will be on for 5 seconds and then it is off, and then motor 2 will be on for 10 seconds and it will be off again. Motor 1 will be on. So this is cyclic movement, cyclic rotations will be there of motor 1 and motor 2 till we operate, till stop button is operated. This cyclic switching of motor will be there continuously. Okay, so this is the required output, and for that first we'll develop a PLC ladder diagram. So ladder diagram is this one. I will open the PLC software to develop the same program. Let me open the PLC software. This is a WPL software, and go to a new PLC program. Otherwise, program is already there. 1 minute, I will just do it from the beginning. Go to new program, SS2, and name of the program, and I will take normally open contact of x0, that is start, and also before that I'll zoom it. This is a maximum zoom, and then I'll take one marker to store the start signal continuously, that is M0. It's a holding or latching concept, M0, and then to have the latching concept I'll have one more normally open and take M0 and click on here on the line 1 and then go for the vertical line, that is F9. It's connected. So whenever you want to erase the data of M0, then you should break the continuity, that is normally close, that is X1, and we call it as stop. Okay, so I think this is understood. So now, by operating X0 once, M0 is continuously on. So with that reference M0, I am going to switch on the motor 1, that is Y0. It is motor 1. Without any delay, motor 1 will be on. Again, with reference of M0, I will count the time, that is F6 application TMR, then T, S1 is T, S2 is K, T1, and 5 seconds, so I will take 50 here. Okay. So what is our requirement? After 5 seconds, motor 1 should be off. So that means normally close I should take it. Normally close of T1. So that is going to switch off motor 1, that is Y0. At the same time, it should switch on motor 2, right? So T1 should switch on the motor 2, that is Y1. That is in the comment section, motor 2. Okay, but motor 2 should be off when? First of all, with reference to M0, we are counting, right? Counting the time, right? So M0, that is T1. If you go to the timing diagram, see a timing diagram, T1 is 5 seconds, T2 will be T1 plus 10 seconds. T1 is 5 seconds, so total 15 seconds. Okay, so with reference to M0, I will take one more timer, that is T2, that is TMR, S1 is T, K, T2 is 150. So what is our requirement? Again, motor 1 should be on. So if motor 1 to be on means I should reset T1. So whenever you switch off T1, then again Y0 will be on. That is motor 1 to be on. So that is what requirement. So I'll first switch off T1. I will switch off T1 using T2. And we should reset, because that is end of the cycle. After 15 seconds, that is end of the cycle. We should reset the timer 2 itself. So we'll take normally close and T2. Okay, and go to the end of the program. Go to simulator should be on. Download the program. Let us check this. It should be in run mode, and then go to X0. If you set on, see, motor 1 is on for 5 seconds. After that, motor 2 is on for 10 seconds. Again, cycle will repeat. So when you press stop button, that is X1, then only in all motors to be off. See, so again you have to operate start in order to start the cycles, or in order to start the operation. Okay, so this is the PLC program. So PLC program is completed. Now we'll go to the HMI screen development. That is a very important part of this video. So open the HMI software, a new project. So we are using 107BV, and then next, and we are using RS485 communication, then finish. Here we can take buttons, that is go to elements. In the elements button is, I'll take maintained switch, or no, sorry, this is can be a momentary, and we'll take one more and double click on this, and I'll type it as X0 because that is a start button. You can design if you want style or round or square, this text is start. Even I want this start after pressing it. Okay, picture, go to vector and general buttons. I'll take this one. Okay, let us take this one. Stretch all is start. And this is top address is x1. Style text is stop. Even when it is operated also I want the display, so stop. Picture, vector, general buttons, and take red. Okay, stretch all. Okay, so start and stop button is there. Now to design the conveyor, first we have to take the, this is very important part, go to the graphic display and then state graphic we have to use. Okay, select this and this element and double click on this. Variables, see we want to create animation like motor. Okay, since our PLC hardware not having the analog output or analog input, so we have to use internal memory. Okay, and then you take one address, maybe 100 or 110, whatever number. Okay, and then in the style option you can take okay, in the picture you can take go to the vector and then fan option. There you can take before that 1 minute before that, go to the main. This is very important. After typing the address, here the type of variable is word, and you take some positions, around say 6 positions. Okay, and then go to the picture and then select vector and fan. So here are the symbols. This one I'll take it, and I'll take, and at the end I'll begin this one. Okay, and stretch all. So this address is 100 I've given. Okay, so I'll copy one more time, and this is like a supporting shaft. Okay, so this is a supporting shaft, this is a driven shaft, and driven shaft what I can do is I'll take indicator, multi-state indicator, and then take it here, double click on this one, addresses, I'll take Y0, but picture I'll take, go to the 100 series, there is a motor, and see here this is a off state, I'll put it, and there is a blue color indication is there when it is on. Stretch all. So click on the motor and right click, there is a rotate option, rotate 90° clockwise. So do it one more time, rotate 90° clockwise. See here, so this is the motor. Okay, but now conveyor belt is not completed, so using the drawing option, there is a line option. Just draw a horizontal line, I want a straight horizontal line. It's not. Yeah, it looks like. And increase the line width. Double click on that. Go to the style. Their line style. Okay, sorry. This is a line weight. You take it 5, and same line just copy and paste, and then take it at the bottom. So this look like a conveyor belt with a motor is fitted there. And what you can do it is, once you done this, you just copy this and paste, because we want one more. But this element address should be different. We have taken 100 here, right? This is, you can take around 200, and this also should be 200. Because when this rotates, this also should rotate, same moment. Okay, but this one, double click on it, and this is y1. Okay, so this is y1, this is y0, this is y1, and this is 100, this is 200 we have taken, this also 100, this is 200. Okay, so this is what the development of screen. But see, PLC is having only digital input as well as digital outputs only. That is Y0, Y1 digital output, X0, X1 is digital input. Okay, but this rotation is possible with help of analog. So we don't have analog. So in that case, we can go for macros. That is, go to project. In the project, there is a macros option here. In the macros option, click on the macro option, background macros. Go to the background macros. Here you have to type the code. Okay, in order to work as motors or conveyor belt. So I'll tell you how it is done. There is a syntax also there. You have to follow the syntax. Okay, so whenever we operate X0, okay, so we know that according to PLC program, whenever we operate X0, first Y0 will be on, right? So whenever Y0 motor is on, motor 1 is on, so this shaft should rotate, right? So how many status we have taken? 6 status we have taken, right? See here, when you click on the state graphic, there are 6 status, six states are there, 6 positions are there. Okay, remember that. So now go to the macro and background macros. Here we have to type the code. That means if input, if output, right, y0, I want my starting point is y0. If y0 is the input output, right? There is an option here, input address. So click on the input address and go to select the bit 1, select bit, and then click on 3 dots, select bit and click on 3 dots, and select y here and y0 input. See here, this is how we can use the input and output. So here double equal and on. So what is our requirement? When motor 1 is on, we want to see the animation like rotation, right? So for that, go to the next line, like this, line number 2. That is, if, what is the address of first wheel? That is $100. So $100 if less than or equal to 6 means it's a starting position. It could be starting position. So go to the line number 3, that is $100 is equal to $100 $100 plus 1. That means you are changing the state of the state graphic by one position. So you are changing by position 1, position 2, position 3, position 2, so that it looks like animation. Okay, else dollar state, yes, $100 status is equal to 0. Okay, so since we are using to if here, so we have to end if 2 times. Okay, that is for motor 1, that is conveyor 1. So I am going to program conveyor 2. So address of second conveyor shaft wheel is, that is $200. So when that should be on, that is second motor should be, that is Y1. So if, so now we have to create the output link or input link, that is bit. Select the bit and then click on the 3 dots and then that is select Y and 1 input equal double equal to on. If that is on, if $200 less than or equal to 6, then $200 is equal to $200 plus 1. So here dollar is missing, it is actually, so it is a dollar. Okay, and else if Y1 is not on, then this also should be dollar, then $200 should be 0, and 2 times end if you take it. That's the program. Okay, and you can go for syntax checking here. It's successfully done. Close, update it. Yes, update macros. So this is what you have to do it. So I'll display 1 second macros, background macros. This is the program. This is the code. This macros code I can also put it in the PPT. You can just refer it. Okay, just practice it, you will get it. So this is the code, and you refer, continue watching this video. You will get the lab demonstration. That means the lab, same program, same PLC program, same macros code, all things we have used, and then we got the output. Okay, and you can go to the download to the HMI, but since we don't have HMI and PLC here, go to the offline. You cannot see the animation here because it's all linked to the real input and output. Okay, so this is what the explanation required to complete this assignment. Thank you for watching this video. See you in the next video. Hello everyone, in this video we are going to solve the assignment number 5, that is controlling the motor 1 and 2. There are 2 motors are there, controlling 2 motors using HMI. So problem statement is, by operating a start button, motor 1 will on for 5 seconds, and after that motor 2 will be on for 10 seconds, and this will be repeated number of times till we operate the stop button. So that is a required animation in the HMI is required. So for that there is a PLC program developed. This is a PLC program, and that is being downloaded to the PLC. So this is a PLC setup, and there is HMI. So HMI screen is also downloaded from PC to HMI. So now we are going to show, that is by operating start button. By operating start button, now cycle start. Now motor 2 is working for 10 seconds. After that again motor 1 will be on for 5 seconds. So this will be repeated continuously. Operate the stop button, so the entire process is stopped. So this is what required, and you can refer my explanation how we developed the PLC program for this, as well as HMI screen, and there is a macro programming is there, macro screen programming. So that is also, you can refer it my explanation video. And the screen and the PLC program, the students have developed. The students working on the program as a part of 2 weeks certification program on PLC, HMI and SCADA.